Good morning, everyone, and I hope you just understand. Hope you just understood what is the basic concept. I mean, what is the what lies in this subject, and as we gone through just introduction to this remote sensing subject, and we already seen what are the different course learning objects of this subject, and also we have seen the what are the course outcomes from this subject. See here, and also we just entered as part of introduction and we were discussing regarding the basic components of remote sensing. So far in the previous class we have seen learning objectives, course outcomes and the syllabus. And as you are aware, the first two units are designed with remote sensing and the followed by units, the followed units, third and fourth units are designed with GIS and last two units are both with remote sensing and GIS. That's what we discussed with respect to syllabus in the previous class. And also we discussed different types of outcomes and different objectives of this subject in the previous session. And we already gone through just little bit, just a brief introduction, line of introduction regarding its remote sensing and how it entered into the world and what is the primitive force behind this remote sensing, as we discussed with an example after the invention of camera almost 150 years back. The roots of remote sensing enters into the world somehow. With the help of camera, in those days, with the help of camera, we used to retrieve the images what we desired. Now with the help of sensors, we are able to get anything on the earth, anything in the worldwide, anything in the world, we are able to visualize what happening around the world. See, and before we are going to discuss more elaborately what happens and what lies in this remote sensing, and before we are going to discuss ABCD of this remote sensing, we just entered yesterday, we just started with the first footstep, that is nothing but introduction. After the introduction, what are the basic requirements, what are the basic requirements of this remote sensing we are discussing. In the previous case, in the in the last session, we have seen that, see, energy is the first basic components of a basic component of remote sensing. We have seen that what type of energy is consumed by the sensors in remote sensing means, that is in remote sensing is electromagnetic radiation. We have seen the sources of electromagnetic radiation also in the previous class. There are two types of energy sources for this electromagnetic radiation, which we termed as energy that is required, that is named for sensors. There are two sources, one is active source and the other one is passive source. What is this active source? If the sensors are able to eliminate the target on the earth with its own capacity, is called as active sensors. If the sensors are unable themselves to hit the target, to take the image on the earth, if and it depends every time on the solar energy to take or as to hit the target, to take the image, we can call it as active sensing, active remote sensing. We can call it as passive sensors. If the sensor depends on solar energy, that is called as passive sensors. If the sensors are activate themselves, and if the sensors are illuminate the target themselves, we can name them as active sensors. We already discussed in the previous class what is active source and what is passive source, and also we just discussed, see here, we also discussed about the target. See here, what is this target here? The whatever the image that is being captured by the sensor, we can name it as a target. See what happening in this remote sensing. See, in the remote sensing, in the past slides, when you are trying to recollect this in the process, the involvement or as the basic principle in this remote sensing technique is detection and measurement of electromagnetic radiation. What is this electromagnetic radiation? Electromagnetic radiation is nothing but the energy that is received by the sensors, that is being sent to the target. Once it hit the target, the same energy will be recorded by the sensors. In that received sensor, in the received energy, the image of the target will be in the form of digital format. Whatever the energy that is being received by sensors, that has to be sent to the processing station. What happening in processing station, that we'll discuss soon. Now what I'm speaking is, in the energy source we discussed, there are two sources, active source and passive source. Coming to the next point, target. The see, remote sensing always works with respect to the reflected energy. The simple classic example is, if you are, see, your iPhone, you somehow you bought one nice iPhone, you bought a nice costly phone, you are starting take the images of your whatever you want. What you are expecting, after you click the camera, the particular image has to be stored in your phone. That means from your phones, the energy is traveling two times. The energy is hitting the person or object, and it has to be stored back into your phone. Then only you can. It is possible to visualize the image of your required position, your required object or person. If the image is not being recorded by your phone, if if the phones are not receiving the reflected energy from the object, even though you bought, even though you have a good highly sophisticated phone with worth of 2 lakhs 3 lakhs, it is just it is just waste. In the same way, if the sensors are unable to receive the energy after hitting of the target, those sensors are waste. Those sensors are not useful. See here, what I'm speaking is the reflected, the story behind the remote sensing is always depends on the reflected energy. If the reflected energy is not at that up to mark, the image will be blur. Simply, I'll give you one nice example here. We are trying to take the image of your friend. Okay, see, and your friend has given nice still based on his own attitude and based on your requirements. See, at the time of you are capturing the image of your friend, you the third person hit your phone. That means if any third person, I mean, what I can say is, if any third person comes to you and if he is trying to shake the phone in your mobile, the moment when you are trying to capture the image of your particular desired objective or your particular friend, that phone may not record the image of your friend. Once again, you are trying to capture the image of your friend. You have just taken the phone into your hands and everything is ready to capture the image of your friend. At particular point of time, the third person suddenly came and he just shake the mobile phone which is in your hand. Even you, if at that particular time, if you are trying to capture the image of that particular person may not be recorded, may not be received by your phone. Even it received, the image may not be recognized. Hope you understood. That means it purely depends on the position of the phone as well as the situation as well as the reflected energy quality. Sometimes, if sometimes the remote satellites are hitted the target, the reflected energy is influencing, or else the reflected energy will be influenced by the target properties as well as atmospheric conditions as well as the motion of the sensors in the platforms. Once again, the quality of image depends on the reflected energy of electromagnetic radiation. See here, the EMR will be influenced by the properties of the target. If the target is not reflecting energy, what we are expecting, the energy after hitting the target, it has to be reflected. Instead of reflecting, if the target is absorbing energy, you won't expect the image. Because for suppose, if the 100%, I mean, for suppose some quantity of energy is hitting the target and expecting the same has to be recorded by sensors, but the target has the tendency to absorb the energy. In such situations, the same quantity of energy may not received by the sensors. That is one point. And the second point is, sometimes even though target reflected the energy, because of the atmospheric conditions that are prevailed in that particular area, the same energy may not received by sensors. That is the second point. And third point, even the target okay and atmospheric conditions are okay, and if the sensor is not in a position. Just now I discussed, and we have gone through one example. By the time of capturing image of your friend, some other friend shake your mobile phone, or some other friend trying to shake your hand, the image may not be stored in the phone that is in your hands. The same way, the reflected energy which is storing after hitting the target is depends on the properties of target, atmospheric conditions, and the platform on which the sensor is fixed. Understand? See here, and the next one is recording of energy by the sensor, what we discussed just now. See here, in the second slide, interaction with the target. If the target properties also one of the influencing factor to receive the energy by the sensors. And the third one is third basic. See, that means we are discussing about the components of remote sensing. We have discussed the first component of remote sensing is energy, and the second component is target. In the energy, we have seen the energy that is required named as EMR, and the sources are active and passive sensors. Coming to the target, target properties are one of the influencing factors for the EMR that is being scanned by the sensors. And the third one is recording of energy by the sensors. See here the sensors, that means this is also one of the basic components. See how it becomes one of the basic components in the sense atmosphere. We can name this, the other name of recording of energy as a component, we can name it as atmosphere also. Just now we discussed, even if the atmosphere is good, if the atmosphere is good, and if atmosphere is feasible for the traveling electromagnetic radiation ultimately which is going to reach the sensor, if it atmosphere is good, the image will be nice. Simply, when you just wake up at 8 o'clock and you are starting to reach the college by 10 o'clock, of course, see, suddenly you observe that heavy rainfall observed from your home, and you may not, your mind may not cooperate to go to college. Understand? In the same way, and even if you try to go to college, even in the two-wheeler vehicle or something, whatever the vehicle you adopted, there is a chance, there is a, I mean, there is a possibility somewhere other way you may be encountered with the rainfalls, and you may not drive your vehicle, you may not drive the car, and you have to face the consequences of the rainfall than the normal days. That means the atmosphere is also influencing you. The way the atmosphere is influencing you, the same way the sensors also influenced by atmosphere. In the previous case, we have seen that the reflected energy is being influenced by the properties of target. One more example. One more example is here. Somehow your friend hit you. You may be quite okay. He is my friend. Somehow you are okay. And somehow if you are the same, the way you beat it, the way you, I mean, the way you call your friend, in the same way you call some other person, definitely you may expect the reflection. That means the I mean, what I want to convey is here, for a single action that you can expect here in this particular example two reactions. Understand? That means the same reflected energy for the target is sometimes it may be absorbed, sometimes it may be reflected. Understand? See here, the recording of energy by the sensor. Recording of energy is always influenced by atmospheric conditions also. This is the third component of, this is the third component of what? Remote sensing, basic components of remote sensing. See, you have seen here, after the energy has been scattered or emitted, the target, we require a sensor to collect the record, to collect and record the electromagnetic radiation. The sensors are popularly, see, just I am trying to read here what you are reading through your online classes. Of course, we just explained the sensors are popularly known by the electromagnetic radiation region they sense. See here, see, once the energy recorded by sensors, again one more concept will start. If the recorded energy is stored in so and so with so and so wavelengths, we named as optical remote sensing. If the energy is stored so and so wavelengths, we can call it as microwave remote sensing. What is so and so here? What is so and so here? Simply see in optical remote sensing sensors. That means the optical remote sensing sensors detects the reflected energy along with the existed solar energy also. This phenomena will be conducted, this phenomena will be taken place especially in the visible, near, middle and thermal infrared wavelength regions. These 3-4 words may be you may think that these are very new words to you. What is this visible, what is this near, and what is this middle and thermal infrared wavelength regions? We'll discuss one after one what. See here, and coming to the microwave remote sensing, if the energy is recorded at one particular wavelength, we can name it as microwave remote sensing. Once again, I'd like to discuss about this third component. The energy is influenced by atmosphere. First thing, based on the recorded energy, we can call this remote sensing process with the two names. One is optical remote sensing, the other one is microwave remote sensing. What is optical remote sensing? If the energy is recorded at so and so bands, all the bands are named with respect to the size of the with respect to the wavelengths category. If they are stored, they're stored along with some amount of solar energy with particular wavelengths. We can call them as optical remote sensing. What is that particular wavelength? In the next slide we will see here. Visible, if the energy is stored in the visible region of electromagnetic spectrum. What is this electromagnetic spectrum? That we'll discuss in the same class. See here, visible 0.4 to 0.7 mm of wavelength. The energy has stored with 0.4 to 0.7 mm wavelength. It is probably, we just name it as optical remote sensing. See all these three, and if the energy is stored at this particular band, we just call this particular point, this particular process or phenomena as microwave remote sensing. See here, keep in mind what is this visible, what is this reflected energy, what is the infrared, what is this microwave region. We are going to discuss at electromagnetic spectrum. In the same session, we are going to discuss. See here, transmission, reception, and processing. We have seen so far three components. The first one is energy. The second one is what? Second one is, ask yourself, even though we are in online, ask yourself. The first one is energy. The second one is target. Third one is atmosphere or recording of energy. And fourth one is transmission, reception, and processing. See here, whatever the energy recorded by the sensors has to transmit to the processing stations, where the processing stations are existed. See here, where the recording has taken place on the, in the sensors, the image was recorded, and the image is in the form of digital format. The digital format has to be decoded, where we will decode. That means at processing stations. What is the processing station here? Processing stations are not the way like supermarkets we examine. We used to observe here and there the so and so supermarket. Here the processing stations, obviously the space research centers, ISRO and IRS and NRSS centers. There the images will be retrieved. See here, what I'm speaking is here the energy recorded by the sensors will be transmitted to receiving and processing station. The first point. And the second point, the processing station, in the processing station, the data will be processed and it will be stored in a digital format. The image is in the form of digital format. The digital format has to be decoded. In the previous session, we have seen that image can be can be able to understand in two ways. One is visual concept and the second one is digital concept. See, you are observing the image. You can observe, oh, okay, the particular person is so and so, particular place is so and so. Instead of the image, if you are observing the negative, you can't interpret the data of the same image what you observed in the previous instance. In the same way, the satellite images are entered, whereas the remote sensing images are stored in the processing station. By applying GIS techniques, the digital the digital coding will be decoded. That's why I said that the output of remote sensing is simply input to GIS. We have seen so far, seen energy, target, and energy recording processing stations, and the fifth one is interpretation and analysis. See, in the processing stations, the data was recorded in a digital format by applying so and so techniques. Which we must interpret the image characteristic features. What are those techniques? The first one is visual image interpretation techniques, and the second one is digital image processing techniques. See here, with this we just finished the subtopic of basic components of remote sensing. See, ask yourself, what are the basic components of remote sensing? Energy, target, recording, that means in atmosphere, and processing stages. Fifth one, analysis. Here now we are going to the next subtopic of this unit, that is electromagnetic radiation. So far we are just keep on discussing, or we are discussing about we will keep on hearing the word electromagnetic radiation. What is this electromagnetic radiation exactly, and what is the source of this electromagnetic radiation, how it enters into the world, that we are going to discuss in this particular point. Electromagnetic radiation. The primary source of this electromagnetic radiation is atomic particles that are released from the sun. The basic source of this electromagnetic radiation is the atomic particle, or as the source of this electromagnetic radiation is the atomic particles that are releasing from the sun. That is the first point. The second characteristic feature of electromagnetic radiation is it propagates through the space of vacuum. While it propagates, initially it enters into the earth atmosphere, and then it interacts with the earth surface, and then finally reaches to the remote sensor, where it interacts with various optical systems and detectors. Here, have a look, 4 points. The first one is source, where it comes, from where it comes. The second one is what it is doing. It propagates into the vacuum of the space. And third one, initially it interacts earth atmosphere, later on it interacts earth surface. Once it interacts the earth surface, it has to be reflected, and that has to be recorded by the sensors at different wavelengths, which we are just divided as optical remote sensing and microwave remote sensing. See here the image of electromagnetic radiation. See, I said that here, have a look over here. The electromagnetic radiation from the space is propagating like this. Right. One more characteristic feature of this electromagnetic radiation is it consists periodical distribution of electric field and magnetic field. It consists periodical distribution of electrical field and magnetic field. Here in the name you are able to observe two words, electro and magnetics. See here, that's the reason that EMR, when the EMR propagates into the space, in the vacuum of the space, and the second point, it consists two periodically distribution of electric field and magnetic field. And the third one is it travels. The speed of this electromagnetic radiation is just equal to the speed of light. What is the speed of light? See here, the speed of light is almost, we just mentioned, is 2.9979245 into 10 power 8 meters per second. One more second. See here, electromagnetic radiation, one electric field and one magnetic field. Electric field and magnetic field. See here, the distance between two successive crests of electric fields is called as wavelength. Understand? Once again, what is wavelength? What are the characteristic features of electromagnetic radiation? The source is atomic particles of sun. It propagates through the vacuum of space. It consists to periodically distributed fields of electric and magnetic fields, and it travels with the speed of light. And the speed of speed of light, the distance between two successive crests called as wavelength. And other one is frequency. The other characteristics features of electromagnetic radiation is frequency. See, the number of these cycles pass through one particular point at one particular time is called as frequency. Once again, the basic characteristics features of this electromagnetic radiation is number one, wavelength. What is wavelength? The distance between the two successive crests of electromagnetic wave is called as wavelength. The distance between two electromagnetic fields is called as wavelength. And the number of cycles that are passing from through one particular point at one particular time, we can call it as frequency of electromagnetic radiation. And the third one, see here, hope you understood. Hope you understood the basic characteristic features of electromagnetic radiation. It enters from the atomic particles of the sun. It travels with the speed of light. It consists electric field and magnetic field periodically distributed. It has the wavelength, the distance between the two successive crests, and I already discussed what is frequency. And coming to that, see here one more point here. See, of course, we discuss speed of course, and here one more. The wavelength, see here, this is one of the image that belongs to electromagnetic radiation with respect to wavelength. When we are moving towards, gamma rays, the wavelength will be shorter and the energy will be high. When we are moving towards radio waves, the energy will be low and the frequency will be low. See, what is this gamma ray? What is this radio that we'll discuss? What I'm speaking is here, the longer wavelength has lower frequency and lower energy, and the shorter wavelength has high energy and high frequency. That's what I want to discuss here. And what is this radio? What is this gamma? We will discuss in the next continuous topic, that is electromagnetic spectrum. See, keep in mind almost 5 or 6 points basic characteristics of electromagnetic radiation. The last point is, if the wavelength is maximum or if the wavelength is longer, the frequency and energy will be lower. If the wavelength is minimum or is shorter, the frequency and energy will be high. Keep in mind. Here, next point is, see here only the last point of electromagnetic radiation. I just mentioned, see one particular point here. See here, there is a wide range of frequency of what? There is a wide range of frequency encountered in our physical world. What is frequency? Number of cycles that are passing from one particular fixed point at a particular time is called as frequency. See, there are different types of such frequencies ranging from low frequency electric waves that are generating by the power transmission lines to high frequency of gamma rays originating from the atomic nuclei. When you made an attempt to bring all those frequencies and wavelengths in one particular point onto the one particular dais, it can frame as a spectrum, that is electromagnetic spectrum. It is like this. Understand what is electromagnetic spectrum? See here, if you made an attempt to bring all those frequencies, low frequencies and high frequency waves onto one particular paper, on one particular place, it constitutes an electromagnetic spectrum. That's what we were going to discuss in this presentation. See, have a look over there. See, there is a wide range of frequency encountered in our physical world, ranging from the low frequency of the electric waves generated by the power transmission lines to the very high frequency of the gamma rays originating from the atomic nuclei. This wide frequency range of electromagnetic wave constitute the electromagnetic spectrum. Hope you understood what is electromagnetic radiation. Now we will discuss about electromagnetic spectrum. See here, what is this electromagnetic spectrum? Simply, see here, the fixing RLs. When simply one, how can you define the spectrum? See here, when you are made an attempt, or else the wavelengths with respect, see the frequency of different wavelengths are being brought together and trying to keep, or else, or else in other way, all those frequencies constitute electromagnetic spectrum, or else representation of different wavelengths. It's different band lines in one particular point, or else onto the one particular place constitute electromagnetic spectrum. Once again, I'd like to define what is this electromagnetic spectrum. Simply, just imagine one example. If if you are trying to send a light through one glass prism, example, assume it. If you are trying to send a light through a glass prism, the light will, once the light, and the light is mixture of different waves. Hope you understood. The light is not in a single constituent. It is in a mixture of different wavelengths with different waves. See here, when the light is passing through the prism, it will bend the other side of prism with different wavelengths. When you made an attempt to keep all those errors, to draw all those bending angles onto a paper, it constitutes electromagnetic spectrum. Did you understand what I said? See, when the light is mixture of different waves, whereas with the different light is mixture of different wave constituents, when it is passing through a prism, it get bends the other end of the prism with different wavelengths. When all those wavelengths are being brought together onto a plane sheet, it constitutes electromagnetic radiation. Sorry, electromagnetic spectrum. Simply, the drawing of different wavelengths and different frequencies onto a plane sheet, we can define in simple word as electromagnetic spectrum. Or as bringing all the wide range of frequencies onto a plane sheet constitutes electromagnetic spectrum. See here, the foundation of remote sensing technology based on the measurement and interpretation of the patterns of EMR. You just remember the previous topic. In the process, what is involved? Detection and measurement. What is this point here? The technology is based on the measurement and interpretation of the patterns of EMR. The second one is EMR is a dynamic form of energy. It transmits wavefront and in the speed up, like that's already we discussed. The whole range of EMR called spectrum. See, different wavelengths and different frequencies, different portion of EMR characterized, or else, and the EMR. See what I want to convey is in this particular slide. All the different wavelengths and the different frequencies constitutes electromagnetic spectrum. See here, the point is, see here, and in this particular point, third point, the visible light that comes, the radiation in the energy that travels and spread out as it goes, and it consists the visible light that comes from a lamp in your house, and the radio waves that come from a radio station are two types of electromagnetic radiation. The other type of EM radiation that makes up the electromagnetic spectrum are microwave, infrared light, ultraviolet rays, X-rays, and gamma rays. Simply, what I want to speak here is, what I want to convey here one more time. See here, just the light is passing, RS. See, the energy that is stored in the sensors will be recorded with different wavelengths. When all those wavelengths are recorded, or as being what all those wavelengths are, trying to keep, or as trying to bond together, it constitutes electromagnetic spectrum. Here you observe, see, gamma rays, X-rays, UV rays, IR, infrared, microwave, and radio. See, remote sensing, the better way, see, all this is the visible range where we have seen that in the previous case. See here, this is the visible region, 0.4 to 0.7 mm. The same is here, 0.4 to 0.7 mm. This is the visible region. And here, when you have a look over there, see here one more other names you observed: reflective infrared, thermal infrared, microwave. All such. See here, infrared. Again, all these are all these are existed side by side. Of course, those thermal infrared are not mentioned here, but see here only based on the wavelength, all they are subcategorized as thermal infrared and other visible infrared. See here, when we have a look over there, see thermal infrared, reflected infrared, all lies here itself with respect to the wavelengths, and it is the microwaves. If the energy is recorded here at this particular band, it is called as microwave remote sensing. If the energy is recorded here at visible bands, where the solar energy also will be recorded, we can call it as optical remote sensing. Understand? Hope you understood. See, if you have any doubts, you are more free. You can make a call and you can ask me in the domain or else in the way whichever you feel convenient. What I'm speaking is here in electromagnetic spectrum. See, all the waves are constitute side by side with respect to the wavelengths. The pattern of representing different waves with respect to the wavelengths is called as electromagnetic spectrum. Today we have seen basic three topics. One is the first topic already we started in the previous class itself. The name is basic components of remote sensing. And the previous class we just discussed up to target. Again, I just given the brush up. I just given the one more time repetition, what is energy and what is target, and we just discussed the rest of the things. And we the way in the way and the same way we just finished basic components of remote sensing. And we discussed today what is electromagnetic radiation, what are the different characteristics of electromagnetic radiation, how electromagnetic spectrum will be is constituted. Okay, and see here, and tomorrow we'll discuss in the next session. In the next session we will discuss, see, we'll discuss with the other topic, see how or what are the different influencing factors on EMR that we'll discuss in the previous class. Keep in mind, and you just have a look after this session. See what have we just recollected after this session. What is EMR and what are the characteristics of EMR, and how the EMR will be, electromagnetic spectrum will be constituted. Because in the previous sessions, almost up to end of the remote sensing, you have to have the basic concept and basic knowledge in our mind, how the spectrum constitute, and how and what are the different basic characteristics of electromagnetic radiation. Then only we may move forward. Simply one more time, one with one particular point, by speaking or as by discussing with one particular point, I'd like to conclude today's session. See, all these are the different bands of electromagnetic spectrum. This is the radio wave band, and it is the microwave band, infrared wave band. The remote sensing images will be stored in these bands, will be stored in these bands. And from here or as in this particular in this particular way, the energy will be received by the processing stations, where this particular the energy wherever stored in these bands will be retrieved. Then only you can get the characteristics of the target, then only you can retrieve the information of the target. Hope you understood. This is what about today's issues and today's topic. Tomorrow we will discuss the followed sessions. Thank you all.